Hi, good afternoon. My name is Langston Fogg. I'm graduating senior, major in electrical engineering. In this video presentation, I'll be demonstrating project 3, which is for mechatronics. Professor is Dr. Ismail. We are doing the robotics 1 project on kinematics. I will explain the homogeneous transformation matrix and how it would derive in the rotation matrix. This matrix is crucial for combining rotations and translations, helping us model robot movements in 3D. I will demonstrate how it works using a two-link robotic arm example. Highlights its importance in robotic control and motion. And just a quick one I will showcase is this here. There's the board, and here's the circuit and the power. So just sooner or later I will demonstrate that. There's 2 programs that we use, which is PSOC and Python coding. Here, of course, is the PSOC, and here is PSOC coding. Each line represents important aspect that is used. We'll go by one by one, which is 14 to demonstrate. Fully explain. Of course, for 1, will impact the linearity for the matrix. 2, define the lengths of arms using rulers that was given us in the box. Our mechatronics kit. 3, define joint angles in degrees. 4, convert joint angle from degrees to radius. 4, construct rotation matrix from frame 0 to 1 using T1. 6, rotation matrix from 1 to 2. Define translation vector from frame 1 to 2. 8, define translation vector from just 1 to 2. 9, rotation and translation vector from homogeneous transformation matrix. 10, adds new way to complete 4x4 matrix. 11, R1 plus R1 and D1 form homo transformation matrix. 12, adds a row to complete 4x4 matrix. 13, H01 and H23 to angle give full transformation matrix, and 14, prints the matrix. All right, here's the second part of the video, which I'll be fully displaying. Servo 1, Servo 2 is programmed from the PSOC to move this marker into a 45-degree angle, which will make a turn like this. Here are the wires and emulated parts that we have constructed, which is using the breadboard. And of course, is being used from the power supply. One is be connected to power to ground. Connections from the power negative will be goes into the VDD. Of course, ground is once connected to the power supply, and the 3 wires, which is 2 connected to the breadboard, which is the positive and negative, and 1 is connected to ground. Now I will demonstrate with the help of my partner of the turn radius that will be formed using the PSOC code. Now see, of course, the little issue that we have is not a purely 45 degrees. That issue is probably come from just the tightness of the wires of the screws here, and how well we gotta emulate the PSOC and Python code. But once again, it's demonstrated that it did complete a 45-degree angle. Of course, it didn't make the markings because of the dried out from the marker, and that somewhat sums up the Servo 1, Servo 2 demonstration. All right, here is back to the Python side, which was used to move Servo 1, Servo 2 45-degree angles. The main numbers that was important here was T1 and T2, which is 45. That represents the angles. This was used to, of course, move, and this is what we demonstrated the need Like for example, if I want to move it to 90, instead of moving halfway, it will move, a quarter away, it will move a halfway. And if I was to put it to 80, it will move, roughly to almost like a obtuse angle. So those are the most important. Here I am going to run it, the code, and I will get these set of numbers with the homogeneous that is needed for matrix 1 and matrix 2. The most popular matrix for matrix 1 is, of course, 0.707, and for 2 matrix, majority of them will say either 1.0 or 4.2. Of course, one's gonna be negative 4.2, some gonna be negative 1, and that sums up the video. Hope you guys are doing well, and you have a good day.